everyone. So as Kevin said, I'm a BIDS fellow, and I'm going to talk about a book that I just wrote. So I do a lot of things. Mostly these top things are software for the physical sciences, in particular nuclear engineering. And the bottom things are things related to education. And I decided that wasn't enough things to be doing. So my friend Anthony Skopatz and I wrote a book this year while I was a BIDS Data Science Fellow. BIDS gave me a great professional excuse to do that. And what it is this O'Reilly book. So O'Reilly, you may be familiar with, is these computational instructional books. There's your bobtail squid there on the front cover, and it's called Effective Computation in Physics. And it goes over various research strategies for computation in mostly Python, but it covers a lot of things. So why did we write this book? Well, so one of the goals of BIDS is sort of to promote reproducibility in the sciences. So you just saw some of that with Karthik. And the idea is basically science is supposed to build and organize knowledge and test explanations about the universe, and it's supposed to do so systematically. It's supposed to do so objectively. It's supposed to do it transparently and reproducibly. Otherwise, you really just can't call it science, right? But this isn't being taught at all in most of our computational sciences. In fact, many people don't even get taught to program. They are simply expected to use programming and computation, in particular in physics, where everyone is very used to teaching themselves a lot of the things they need to know to conduct their research. So if there's a book you want to read, then if it doesn't exist, you have to write it. This is the way that my friend Anthony talked me into writing this book with him. And it involves a couple of things that are supposed to take someone from 0 to 60, especially people in their later years of undergraduate and their early years of their graduate work, but also early postdocs who haven't done computing before. It's supposed to get them started in things like the shell. So the first 6 chapters are related to that. The shell, basic concepts in Python, basic data structures, basic object orientation. Okay, once they're done with getting started, they need to actually produce code. And to do so, they need to use the right kinds of analysis and visualization workflows that are going to be more efficient for them. So that's where the effectiveness comes in. We teach a little bit of SciPy in various ways. We teach HDF5 because it's physics. But a lot of people could use this well outside of physics. And in fact, the book is targeted to everyone in the physical sciences, but could be easily read by people outside of the physical sciences. It would be a great course book for anyone starting graduate students off in a research curriculum. Now, getting it right is key also. So we talked about science being reproducible. And all of this has built up to a situation where you can do things like profile your code. And getting it right involves building really robust software pipelines, testing your code, version controlling it, and being able to debug it. So these chapters in this section really focus on that reproducibility and the ability to verify and validate your code. Finally, a huge part of science is making sure that it is available and transparent to your community. Your scientific community needs to see it, or else it doesn't really advance science, does it? Like a paper in the forest doesn't really advance the field unless other people read it. And so we talk a lot about GitHub, documenting your code, how to publish your code in a reproducible, readable way, how to collaborate with people in your field using these open source tools that are really, really common in software development today, and how to be careful about licenses and ownership and copyright in a way that academics really need to know. And then we talk a little bit more about the philosophy of it and the book. This is my friend Anthony, who just became a professor, and he and I wrote this book together. So I'd like to acknowledge him. We actually would really like to see this become an early course for students in the physical sciences interested in computational research. If you're interested in that at all, or if you're interested in reading the book and you feel like you could brush up on a few of these cool things, I actually have some discount cards, a finite number of them. I can give you guys a little discount to buy the book. But actually, most professors can get books for free on O'Reilly, too. So if you're a professor, that's also possible. Ultimately, I have to say, though, that this book couldn't have possibly happened without Software Carpentry and The Hacker Within, which are incredible educational programs that try to do all of this educating for these kinds of topics across many disciplines. And so Actually, Greg Wilson, who is the executive director of Software Carpentry, wrote the foreword to this book, and we're very thankful for all the years that we've been collaborating with him, Anthony and I. So that's it.